In this video, I will show you how to factor polynomials using a variety of techniques, including factoring out the greatest common factor, using the difference of squares pattern, or both, and then after that we're going to move on to factoring by the box method or grouping, which is how we factor trinomials. Alright, for number 7a, we have to explain why this polynomial cannot be factored using the difference of squares pattern. Well, the D in DOS stands for difference. Difference means subtraction. But this problem is addition. This is the sum of squares, not the difference. So that's why it cannot be factored using the difference of squares pattern. So this is a sum, not a difference. Well, what's wrong with this one? Well, this is the difference, and x squared is a square, but 8 is not a perfect square. Perfect squares are numbers like 1 and 4 and 9 and 16 and 25, etc. Alright, numbers that could be written as something times itself. But notice that 8 is not on this list. Alright, it goes straight from 4 to 9. There's no 8. So, we will simply write that 8 is not a perfect square. Alright, for the next couple problems, we need to factor each polynomial completely using greatest common factor, difference of squares, or both. So, always look for a greatest common factor first. Yes, both of these are divisible by 3. However, that's not the greatest common factor. Both of these numbers are divisible by 9. So we're going to use 9. Also, they both have variables in common. What's the lesser amount? X squared. So the GCF is 9x squared. Then we're going to have parentheses that will contain whatever is left behind. What goes in the parentheses, you divide by your GCF to find out. So if I divide everything by 9x squared, the 9's cancel out. X to the 6th power divided by x squared is x to the 4th power. 36 divided by 9 is 4. And the x squares cancel each other out, so I just have 4. Now, look at this red part. This is now the difference of squares. 4 is a perfect square. So, let's keep going, and we will break this down. We will factor this using the difference of squares pattern. So x to the 4th power will become x squared times x squared. We will have 1 plus and 1 minus, as we always do for difference of squares. And then 4 can be factored as 2 times 2. Please do not forget to bring down the GCF of 9x squared that you pulled out in the first place. So this is the final answer for 8a. Okay, looking at 8b. Both of these are divisible by 5. The second number has no x's, so that means the GCF is simply 5. I'm going to set up my parentheses for the leftovers. And again, to figure out what goes inside, I'm simply going to divide by my GCF. So these 5's cancel each other out. That leaves x squared. I believe 125 divided by 5 is 25. So I'll have plus 25. Now, am I going to keep going and factor this down further? No. That would only work if this were subtraction, if this were the difference of squares. The sum of squares cannot be factored. So this is the final answer. Okay, for problem number 9, we need to find two numbers that have a product of one thing and a sum of something else. So what we do is we start with the product. See that 30? I'm starting with the 30. Now I'm going to make a list of all the ways I can multiply and get 30. Alright, so 30 could be 1 times 30, or it could be 2 times 15, or 3 times 10, or 5 times 6. These are all of the ways to make 30. Now, which one of these pairs can make a sum of 13 if I pick the signs right? Well, I have two choices. Okay, I could make 13 with 2 and 15 if I had a negative 2 and a positive 15. I could also make a sum of a sum of 13 out of these if they were both positive. Okay, so again, to make positive 13, I would need a negative 2. And for this one, they would both be positive. Now, to make a positive 30, the negative 2 times 15 would not work. So that's why the answer is going to be 3 and 10. I wanted to use the bigger ink. I'm going to use 3 and 10 because 3 times 10 is 30 and 3 plus 10 is 13. Okay, now we're switching gears. So now we want a product of negative 30 and a sum of negative 13. So I can still use this same list here. I just need to adjust my signs. So look, we can just focus on these two pairs. Okay, I want a negative 30 this time, and I want a negative 13. So let's see, to make a negative 13 out of the first pair, I would need a positive 2 and a negative 15. Okay, that would be a sum of negative 13. Now, that would also make a product of negative 30. So we have a winner right there, 2 and negative 15. Okay, this time the 3 and 10 would not work because in order to make negative 13, both of these would have to be negative, but that would make positive a product of positive 30, which is not what we want. Well, it's not what we want yet, because look what's coming. Okay, now looking at the last example, this time we want a product of positive 30 and a sum of negative 13. So again, if I try to use the 2 and the 15, to make negative 13, I would need the negative 15 and a positive 2. But that's no good because that would make negative 30, and we want a positive 30. But if I want a negative 13, and I use the 3 and the 10, I could get that by doing a negative 3 and a negative 10. Okay, that would make negative 13. But negative 3 times negative 10 is positive 30. A negative times negative is a positive, and that's what I want. So that's why I would use negative 3 and negative 10. Alright, on number 10, we're to factor each polynomial using the box method, grouping, or another method that works. You may use any method you like, but you must show work. Most of my students prefer the box method over grouping, so I am going to use the box method. For the box method, we need a product and a sum. The product comes from doing A times C, 1 times 10, so that's going to be 10. The sum is just the B value, which will be negative 7. Now, let's start with the product. So I'm looking at the 10. Now, let's think of all the numbers that would multiply together to make 10. So, for example, 1 times 10, or 2 times 5. Okay, so these are the pairs that would multiply to make 10. Now, which of these pairs could add up to -7 if we chose the signs right? Well, obviously that's the 2 and the 5. So I'm going to use the 2 and the 5. In order to make -7, both of these would have to be negative. So we use the same exact numbers for the product, -2 times -5, and that makes +10. So that works out great. So these are the numbers that we need. So this is the box method, so now I'm going to go ahead and draw the box. So the box works like this. Alright, in the first square I put the first term, so I have x squared. In the last square I put the last term, so I will have 10. Okay, in the other two terms I use the two numbers that we just found. Please understand that I'm really, what I'm doing is I'm splitting up the middle term into two numbers, into two terms. So that's why I'm going to have -2x and -5x, because that makes -7x. So I will put those here and here, -2x and -5x. Okay, now we do the GCF of every row and every column. The GCF of the top row is x. The GCF of the bottom row is -2. I'm calling it -2 because the first term is negative. The GCF of the first column is x. The GCF of the second column is -5. Again, I'm going with -5 because the first term is negative. So this gives us a binomial times a binomial. X minus 2 from the left and x minus 5 from the top. And this is the final answer. So that's how you factor using the box method. Okay, I'm going to factor this using the box method as well. Again, we are going to need a product and a sum. The product comes from A times C. 2 times -2 is -4. The sum is simply the B value, so that is -3. We start with the product, which is 4. I'm ignoring the sign. Now, I need numbers that multiply to make 4. For example, 1 and 4, or 2 and 2. And really that's it. That's the complete list. Now, which of these can make -3 if I pick the signs right? Well, it's the 1 and the 4. 1 and 4. I can make -3 out of this pair if I have a +1 and a -4. So let's go +1 times -4. Guess what? That's -4. So, time to make the box. Alright, in the first square goes the first term. In the last square goes the last term. In the other two squares, we put the two numbers that we just found, 1 and -4. But we are really splitting up the middle term into two terms. So this is going to be 1x and -4x, which is the same as -3x. And I will put those here and here. Then it's time to do the GCF of every row and every column. Now, the GCF of the top row is 2x. The GCF of the bottom row is 1. Nothing divides into both of these other than 1. The GCF of the first column is x. And the GCF of the last column is -2. I'm calling it -2 because the first term is negative. Now, that gives me a binomial times a binomial. 2x plus 1 comes from the left, and x minus 2 comes from the top. And this is the final answer. Okay, I'm going to do this one problem by the grouping method, but then I'm going to erase it and do it over again by the box method. So it starts off the same. We still need a product and a sum. The product still comes from A times C, which is going to be 6. The sum still has to be the B value, which is -7. So as always, we start with the product. Alright, we start with 6. What are all of the pairs of numbers that will multiply to make 6? Well, that would be 1 times 6 or 2 times 3. So that's the complete list. Now, which of these pairs can make a sum of -7? Well, the first pair. I could make -7 out of 1 and 6 if both of them were negative. -1 plus -6 is -7. Well, what about -1 times -6? Well, that's +6, which is just what we wanted. Okay, so far that's exactly the same as the box method. In fact, when I erase this, I'm not going to erase this part. But instead of making a box, here's what we do. We take the first term and we just bring it straight down. So I have 2x squared, I just brought it down. I'm going to take the last term and I'm going to bring it straight down. Boom, +3. Alright, I just brought that down. Now, the more interesting thing is the middle part. Okay, for the middle term, we are going to split this apart using the two numbers that we just found. So instead of writing -7x, we're going to write -1x and -6x, because together that makes -7. So I'm going to put -1x minus 6x. I'm not going to put plus negative, I'm just going to put minus. Alright, so hopefully you can see that I haven't changed anything. This still has the same value. If I combined like terms, I would immediately get -7. I've just split it apart in a certain way. Now, what I do next is GCF. I want to take the GCF of the first two terms and the GCF of the second two terms. So, the GCF of the first two terms is x. So I'm going to take that x and put it out front. That's going to leave behind some leftovers in parentheses. To figure out what goes inside the parentheses, I divide by my GCF. So let's see, that's going to be 2x, because one of the x's will cancel. These x's cancel, and so that's going to leave -1. Next, I turn my attention to the other pair of terms. What's the GCF? Well, both of these are divisible by 3. So I'm thinking that 3 is the GCF. However, because the first term is negative, I'm going to go ahead and call it -3. And then I'm going to have parentheses with the leftovers. Once again, to know what goes inside the parentheses, I divide by my GCF, -3, not +3, but -3. So what goes inside? Well, -6 divided by -3 is +2. So this will give me 2x. And then +3 divided by -3 is -1. Okay, so notice that the parentheses are the same. That means that 2x minus 1 is a common factor. So anytime we have a common factor, we take it and we put it out in the front. So I'm going to take both of these as 1 and put it in the front. So I will have 2x minus 1 in the front. And then I will look and see if I take away the 2x minus 1, what's left? Well, what's left is this blue part, x minus 3. And that's what, whoa, that's big. that's what goes in the other parentheses. Okay, so this would be the final answer, 2x minus 1 times x minus 3. So that's how you factor by the grouping method. Now, like I said I would, I am going to erase this, and I'm going to go back to here, and now I'm going to switch over to the box method. Alright, I just wanted to show the grouping method one time. So back to the box method. Alright, of course we should get the same answer. So, box method. The first term goes in the first square, the last term goes in the last square. And then for the other two squares, we use the two numbers that we just found. So I'll put the negative 1x and the negative 6x. Then we do the GCF of every row and every column. So the GCF of the top row is 2x. The GCF of the bottom row is negative 1. Nothing divides into these, but since the first term is negative, I'm going to call it a negative 1. The GCF of the first column is x, and the GCF of the second column is negative 3. Again, I go with negative 3 because the first term is negative. This will give me a binomial times a binomial. 2x minus 1 times x minus 3. Alright, from the side and the top. And for this problem, this is the final answer, which is the same thing we got by the grouping method. Okay, let's do the box method again. So we're going to need a product and a sum. The product needs to be a times c, 9 times 1, which is 9. The sum needs to be the b value, which is negative 6. Let's start with the product, which is 9. Now, what numbers multiply to make 9? Well, we could use 1 and 9, or 3 and 3. Those are the only pairs that multiply to make 9. Which of these pairs can make negative 6 if we pick the signs right? Well, that'll just be 3 and 3. We'd have to have negative 3 plus negative 3 to make negative 6. But then we need to do negative 3 times negative 3, and that is positive 9. So we found the pair that we need. So this is the box method, so you know what we have to do. Okay, in the first square goes the first term, so 9x squared. In the last square, we put the last term. In the other two squares, we take the middle term and we split it up using the two numbers that we just found. So we're going to have negative 3x and negative 3x in the other two squares. Now it's time for the GCF. The GCF of every row and every column. The GCF of the top row is 3x. The GCF of the bottom row is negative 1. Nothing divides into these, so normally I think 1 is the GCF. But since the first term is negative, we call it negative 1. The GCF of the first column is 3x. And the GCF of the second column, once again, is going to be negative 1. So that's going to give us a binomial times a binomial of 3x minus 1 from the left and another 3x minus 1 from the top. So this is the final answer. Okay, if we are very clever, we could write 3x minus 1 squared, since there's two of them. Okay, but most students will probably leave it like this. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.